This is Algebra 1, Lesson 10-15, the Quadratic Formula. Today's date is Wednesday, April 29th, 2020. So our objective today is to memorize the quadratic formula and use it to solve quadratics. So this is where I have kind of a big tangent, and if you want to skip ahead in the video to where I actually solve or start doing the notes, then please do so. I will have a lot of negative karma, I guess, or something on my conscience if I don't say this. I don't want to teach the quadratic formula this way. I think that the quadratic formula by itself is kind of cool, but it's also a focal point when people say why we shouldn't learn mathematics in school. They usually reference this formula. They say this is a useless formula. Everyone had to learn it. Like if you talk to your parents, they probably remember the quadratic formula. And you'll probably ask like even people at NASA, do you use a quadratic formula? And they might. I mean, if you're really involved in math, you might use it a bit, but typically you're never going to see the quadratic formula. But the cool thing is, especially this last week, one of my favorite YouTubers, 3 Blue 1 Brown, he released a video, a live stream really, of explaining where the quadratic formula comes from in a way that makes a lot more intuitive sense. And it took him an hour to do, and it was beautiful. It was amazing, and I was stunned that I did not learn the quadratic formula that way. I can't do it that way for you because it's as beautiful as it is. It took an hour to do, and my goal, as much as it doesn't seem so while I'm on this tangent, is to try to deliver you the material in as an efficient package as possible so that you can learn it quick, solve it quick, get a good grade on the quiz and test, and be done with it, and then forget it. I know that maybe makes me want to cry, but that's the general idea, because I know that the majority of you are probably not going to go on to study mathematics. And for those of you that do, I am tentatively planning on teaching the type of lesson that 3 Blue 1 Brown did this Thursday for, I don't know what we're calling it, but like mathletes type of thing. I want to teach that lesson because it is beautiful and it's really, really cool. So with that, let's go ahead and start on the notes. Boiled down, here's the formula. If you have a quadratic, ax squared plus bx plus c, and I set that equal to 0, it has to be in this form. It can't be in a form that looks like this down here. There's no 0 on the right hand side, right? Notice that I'm arranging my terms from greatest powers or greatest degrees to lower and lower degrees until I just have a constant term here. So they do have to be arranged correctly. If everything is set up correctly, then I'm only going to look at the coefficients. I'm only looking at the a, not the x squared. I'm only looking at the b, not the x, and then I'm looking at the c. I'm kind of ignoring all of the variables. The cool thing with the quadratic formula is if you know it and you have a quadratic, you can immediately just plug and chug. You will get an answer. And I'm going to go on a mini tangent. That is important. The quadratic formula is cool because, yeah, it can just solve any quadratic. And then that leads to a natural question. Well, is there an equation that can solve anything that's like a cubic, like something with ax cubed plus bx squared, etc., with the highest degree term of 3? And the answer is yes. It's a really hard formula, but you can do it. Can you do anything with x to the power 4? And the answer again is yes, and it's really, really intensely difficult. And then the cool question is, can you do anything to x to the power 5? And the answer is no. Not randomly, I guess, but all of a sudden it becomes no, and that's known as I think it's pronounced the Abel-Ruffini theorem, which basically states that there's no solutions to radicals, no solutions in radicals to polynomial equations with degree 5 or higher. And it's a cool area in math, like how do you derive these formulas? Typically in high school, I think we might actually be able to get into this. This unit is, you can derive this just from completing the square, but there's a much more beautiful way of doing it, and I'm going to be talking about that on Thursday. Definitely be recording it for you guys, and if you just want to, you can just Google it right now, 3 Blue 1 Brown quadratic formula. It's a live stream. Okay, so what is the formula? And typically it's a very sing-songy way of writing it. It's the easiest way to memorize it. I'm going to write it out first. So it's negative b. That means I'm taking this coefficient and I'm making it negative. So that negative coefficient plus or minus, because there's going to be two answers, one with plus, one with minus, the square root of b squared, so again using b, minus 4 times a times c, or just 4ac. And then this entire thing is going to be divided by 2 times a. So the way that you can memorize this is by turning it into a song. So are you guys ready to hear Mr. Sindel sing in a horrible way at 1 in the morning? Here we go. x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And you can repeat that. I'm not going to do that again anytime soon. It's embarrassing. But it's the song that you should be singing in your head to help you memorize this. You have no idea where it comes from. It's the quick lesson, right? But there's the formula. Let's plug and chug and see if it works. So this is a type of problem that you might encounter on Khan Academy. Notice it's not in the correct form, so let's go ahead and get it in the correct form. So first I need to have the x squared term out front, and I need to have this 10 on the other side. So those are the two main problems that we have to deal with. So I'm going to go ahead and add 10 to the other side and move that negative 7x squared a little bit to the left. So my new equation is negative 7x squared. Notice that the negative moves with the 7x squared because it's a negative 7x squared. And then I'm going to add the 2x because this is a positive 2x. And then now that I've added 10 to both sides, I have a plus 10 on the left hand side and a 0 on the right hand side. Hopefully you could follow those kind of 3 steps all in one line. Okay, so from here I'm set up for the quadratic formula. Look, it looks like this form now where it has descending degrees. It's equal to 0. Here we go. So if it helps, I think it'll help on this problem. I won't do it for the future problems, but what are our values of a, b, and c? Well, a is equal to negative 7, b is equal to 2, and c is equal to 10. Ignore the x. In fact, ignore everything that's here now. I have these values, plug them into this formula, done. You basically write it like that formula. Especially on Khan Academy, it just asks you multiple choice, A, B, C, or D, which of these formulas is correct. And it even has the plus and minus in there. So negative b, I'm just rewriting the formula, right? Negative b is negative 2. So I say x is equal to negative 2 plus or minus the square root of b squared. So I'll have to do a little bit of simplifying, but I'll leave it as 2 squared for now, minus 4 times a, which is negative 7, times c, which is 10. And then all of this is going to be divided by 2 times a, or 2 times negative 7. Okay, I mean, that's the answer. I'm going to simplify it just a little bit. So I have negative 2 plus or minus the square root of, okay, what's happening inside that radical? 2 squared is 4. And then notice I have a negative times a positive. That's all going to be equal to a positive. So I'm really going to be saying 4 plus here. 4 times 7 is 28. Add on a 0. So 28 with a 0. And that's still all being divided by. I'm going to leave it as 2 times negative 7 for now. Just because the 2's will cancel out here. So I think on Khan Academy sometimes they split it up into 2 different fractions too. I'm pretty sure they actually do that pretty often. So my final answer here, and I'll do it in red for my final answer, x is equal to, my first fraction is this one without the plus or minus. So the 2 and 2 are kind of cancel each other out, and then the negative and negative are also going to cancel each other out. So nothing is on the top. So when there's nothing, you leave a 1 when you cross cancel, right? So I have a 1 on the top. Actually, I should leave those things canceled. Chunk, 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 chunk. So I have 1 over 7. That was this fraction right here. And I'm going to say plus or minus this second fraction right here. And again, nothing is cross off for that second fraction. It's just going to be the square root of 284 divided by, and it's going to be negative 14. Cool, and that's our final answer. Note that I can write it like that, or I could have written it the other way of writing it would be just negative 2 plus or minus the square root of 284 over negative 14 like that, where it's one giant fraction instead of 2 fractions that equal to each other. So both of those are valid answers. And I want you to take away how kind of cool it is that you have something really hard. In fact, there's no way that you can ninja star this and you can get an answer. What we basically have given you, I as a teacher have given you, is a hammer. This hammer will work on any quadratic, even quadratics that give you no solutions, and we'll talk about those at another date. But as a preview of things to come, what happens if this number right here is negative? What happens if I was subtracting a really big number over here and it's negative? What does that mean? Let's try another example and then we'll be done. So again, I need to move this 12x over, so I'm going to add 12x squared to both sides. So 12x squared plus 2x squared is 14x squared. And the next thing that's going to come is the negative 7x to be in the correct order. So minus 7x and then plus 1. That's set equal to 0. I have it all set up, so I know my A is 14, B is negative 7, C is 1, and plug it in. So x is equal to negative B, so negative times negative 7 is positive 7, plus or minus square root B squared, so negative 7 squared minus 4AC, well A is 14 and C is 1, all over 2a, so all over 2 times 14. Okay, and there it is. I just have to simplify it a little bit. So notice I have 7 and 14 that can cross cancel, so there's going to be 2 different answers that you can look for Khan Academy. I'm going to leave the easiest one, like the one fraction that I had right there first. So I have 7 plus or minus, okay, I have in the radical symbol, I have 49, and I made a bad problem, didn't I? This has a negative in there. How can I make this a good problem? What if I made this a negative one? That is now a negative one, which means that's a negative one, which means that's a negative one. Sorry for that, because otherwise I'll have no solution here. I think, because 4 times 14 is 54. Yeah, so 54 is bigger than 49. Dang it, I messed up. Okay, so it's going to be plus now because I changed the problem. A negative times a negative is a positive. 4 times 14, as I said before, is 56. 56, and that's all going to be divided by 2 times 14. I'll just leave that as 28. 28. Cool. And simplifying one step further, this is our final answer now, by the way. X is equal to 7 plus or minus 49 plus 56. That's essentially 50 plus 55, right? If I just take 1 from here and add it to here. So what's 50 plus 55? Well, that's 105. So it's going to be 7 plus or minus square root of 105 divided by 28. Perfect. So that's one answer. And then the other way that you can picture this is 2 fractions. So the first fraction is 7 over 28, which reduces to 1 over 4. So 1/4 plus or minus, and then square root of 105 over that original fraction, 28. So both of these two are our answers. Look for either of them in the multiple choice for Khan Academy. That concludes Notes Algebra 1 10-15. I'll see you guys tomorrow.